Grade 11, Precal, lesson 33, adding and subtracting rational expressions. Now, the key when you're adding or subtracting rational expressions, you have to have common denominators. So what we'll do is we'll do 3 examples first with common denominators and then 2 without. Okay, so let's look at this first one. If you notice, they both have denominators of b. So then all we have to do is take the numerators, 2a minus 1, and subtract them. Now, be careful. That subtract applies to that whole a minus 1. So we're going to toss it in brackets. So then we can distribute the negative to both those things. So then we end up with 2a minus a plus 1, all over b still. And then we do collect like terms. So 2a minus a is just a, so a plus 1 over b. Your NPV is b cannot be equal to 0. Remember, when it's just a variable by itself, you just set it equal to 0, and it is that. Next one, 2x over x plus 4 plus 8 over x plus 4. And if you notice, common denominators, both of them are x plus 4. So all you do is take the numerators and add them together. There we go. So 2x plus 8. Now, what you got to realize is, 2x plus 8, there's a GCF there. I can pull that out. So I take out a 2. Take out a 2, and I'm left with x plus 4. Oh, look, I can reduce those. So those reduce down to 1. So your answer is just 2 in the end result. But you still have to remember the NPVs. The NPVs have to be, you have to look back at the beginning. So x plus 4 set it equal to 0. So x cannot be equal to negative 4. That's your NPV. Okay, the next one. If you look at this one, oh, look, they're all x minus 2s. There's 3 in this case, but it really doesn't matter. They're all x minus 2. So we got an addition and we got a subtraction. Okay, so what we do is we take the numerators and we x squared plus 3x minus 10. Just put it at the top. And then you have an x minus 2 at the bottom. Then what you do is, you look, okay, can I factor that? Yes, I can. I can factor that into 2 binomials. So when we factor into 2 binomials, we end up with x minus 2 and x plus 5. Oh, the x minus 2's reduce. So we're left with just x plus 5. But you still have to remember the NPVs. What was the NPV back up here? Set that equal to 0. X cannot be equal to 2. Okay, now those are pretty easy when the denominator is the same. Flip the page and we're going to do some without common denominators. All right, let's look at this first one here. So we have 2x over xy plus 4 over x squared. Okay, that's pretty complex. So what you got to do is you got to figure out your LCD first. You got to figure out your lowest common denominator. Now, you could, if you wanted to, do x times x squared and get x cubed and then y, but that's a common denominator, but that's not the lowest one. The lowest one is a denominator that they both go into. Does xy go into x squared and y? Yes, it does. Does x squared go into x squared and y? Yes, it does. So our LCD in this case is not x cubed y, it's x squared y. So we look at the first one. We have xy. Well, how do we get to x squared y? We times both the numerator and the denominator by 2. The second one here, we have an x squared. How do we get it to x squared y? You times both the numerator and the denominator by y. So we do that. We end up with 2x squared over 2xy plus 4y over x squared y. Now, do we have common denominators? Yes, we do. So we can take the numerators and just add them together. So we end up with 2x squared plus 4y. You could, in this case, take out a 2 if you wanted to as a GCF, but it's not going to help you because you can't reduce the x squared y on the top and the bottom because they're separated by an addition. So we just go on to doing NPVs. Now, if you look, there's an x and a y. Both are equal to 0. So NPVs, x cannot be equal to 0. Y cannot be equal to 0. The hardest part about this whole unit will be finding the LCD, the lowest one, right? LCD, common denominators are easy. The lowest one is a little bit difficult. Okay, let's look at this next one here. So let's factor this first to kind of see what we got here. So we got a y squared minus 20. That's not a difference of squares because you can't take the square root of the 20. This one is the y squared minus 4. That is a difference of squares. So we factored that down to y plus 2, y minus 2. Now, if you look, we got a y plus 2 here, a y minus 2, and a y plus 2 here. So the LCD is not going to be all 3 of those together. It's just going to be y plus 2, y minus 2. Nice and easy, this one. So this first one, we don't even have to touch because it already has the common denominator. But this one, we got to multiply both the top and the bottom by y minus 2. That'll get us our common denominator. Okay? So we break it down, and you can see here we have y squared minus 20 plus all of this. We're going to FOIL this in a sec over y plus 2, y minus 2. So we FOIL this. We end up with y squared minus 4y plus 4 all over this again. You'll find you write things down a lot in this one over and over again because you're working through the steps. Then you combine like terms. Then, of course, we're going to try to reduce. Like anything, you always try to reduce. So here, we can take out a 2. Pull out a 2. We end up with y squared minus 2y minus 8. Oh, look, we got a trinomial. Let's try to factor it. So we go down here, and this factors into y minus 4 and y plus 2. Now, look, Since these are all multiplied and these are all multiplied together, we can actually reduce. So we can take the y plus 2's out of there, right? They reduce down to 1, and we end up with 2, y minus 4, and y minus 2. Now, you got to remember your NPVs are always before you do any of the reducing. So your NPVs could be anywhere here. So you can see y cannot be plus or minus 2 because if we plug those in, that sets the denominator equal to 0, which is wrong. You just can't get it. Okay. So these ones, just be very careful. Finding common denominators, always find the LCD. It'll save you a lot of work, and it'll make it a lot easier if you have the lowest one to start with.